Hey guys, in today's video I'll be talking about the laws of exponents. We'll go over all the laws as well as doing some practice problems to help you build your knowledge. And to begin, I'll start with explaining what an exponent actually is. So if you have a to the m, first of all, this is called the base, and the power here is called the power. So what this means is a to the m is equal to a times a all the way up to m times. So let's say you have 2 to the power of 2. So this is just equal to 2 times 2, which is just 4. And that's basically an overview. Now we'll be going over the exponent laws. To begin, there's something called the product rule. So essentially, if you have something like a to the power of m times a to the power of n, this is equal to a to the power of m plus n. And notice that over here they have the same base. So in order to use the product rule, it has to have the same base. So if it was something like a to the m times b to the n, if a is not equal to b, then you can't use the product rule. Okay, then similarly, there's also called the quotient rule. So it's similar to the product rule. So you have a to the m, and instead, if you divide by a to the n, it's just equal to a to the m minus n. So you could see instead of a plus, it is a minus. And over here, you could just rewrite this as a to the m divided by a to the n in fraction form, which is the same thing. Next, I'll be going over the power of a power rule. So power of power rule, I'll just call it the pop rule for short. So let's say you have a to the m in brackets all to the power of n. So this is just equal to a to the m times n. So this only applies if you have exponents that's getting exponented again, which I don't know if that's the right word, but whatever. Okay, next rule, we have the power of a product rule. Power of product rule. So it's similar. So instead of just having one thing in the brackets, let's say you have ab to the power of m, and that is just equal to a to the m times b to the m. Also, there is the zero exponent rule. Basically states if you have a to the power of 0, that is equal to 1. And that's very simple. And then you also have the negative exponent rule, which basically states if you have a to the power of minus m, that is just equal to 1 over a to the m. And this is very useful if like you're solving an equation and you end up with a negative power. You could always make it positive. And last one, we have the fractional exponent rule. So fractional exponent rule. So if you have a to the m to the n, that is equal to the nth root of a to the power of m. So for example, you know how you could have a square root of x. Well, what this rule is stating is that's just equal to, there's a 2 here, square root. Okay, so that's just equal to x to the power of 1/2. So that's just equivalent. And those are just the basic exponent rules. So now we'll be going over some examples. Okay, so these are 6 problems that we'll be working on. And if you want, you could pause the video and try them first yourself. If not, we'll continue and solve them right now. So starting with question 1, it's very simple. You just apply the product rule. So this is equal to 2 to the power of 3 plus 5, which is just equal to 2 to the power of 8. For question number 2, you have to apply the power of a power rule. So this will be, you'll multiply the exponents, so you'll have 4 to the power of 5 times 4, which is equal to 4 to the power of 20. For question number 3, you may think that you have to apply the product rule, and you'll be right, you do. But first, notice that the bases are not the same, and one of the criteria for product rule is they have to be the same. So you could notice that 9 is, it could be rewritten as 3 to the power of 2, which will make the bases the same. So you'll have 3 to the power of 2 times, in brackets, don't forget this, 3 to the power of 2 to the power of 2. So this just simplifies to 3 to the power of 2 times 3 to the power of 4 by applying the power of a power rule, and then apply the product rule, and you get 3 to the power of 6. For question number 4, you have to apply the power of a quotient rule. So this just simplifies to 4 to the power 4 squared, and then divided by 5 squared, which is just equal to 16 over 25, and that cannot be reduced further, so just leave it as that. For question number 5, there's 2 ways of doing it. First way would be, notice that there's a -2 in the first exponent. So first what you could do is just use the negative exponent rule and rewrite this as 1 over 2 to the 2 times 1 over 2 to the 3, and then apply the product rule, and you have 1 over 2 to the 5. Or you could skip that and just go to the quotient rule, and you could have 2 to the power of -2 divided by 2 to the power of 3. So that would be -3, which is equal to 2 to the power of -5, which you know is the same as 1 over 2 to the 5. So they get the same answer. Similarly, for question 2, there's 2 ways of doing it. So you could notice that 4 over 2 is just equal to 2. So simply, you could just rewrite this as 2 to the power of 2, which is 4. Or you could apply the fractional exponent rule, and you'll have the square root of 2 to the 4, which is equal to the square root of 16, because 2 to the 4 is 16, which is equal to 4. And yeah, that's basically it. All these problems are solved, and thank you for watching. If you found this video helpful, please like and subscribe. And if you want me to make videos on specific topics, please comment down below so I can work on that. And yeah, thank you for watching once again.